me. Now let's go with this, and we are going to talk about the data types over here. Now next is, here I will give it as integer. Integer, integer data. Inside this, we are going to start with the integer. So first, we know that what is a variable and what is a value, and value will occupy the memory, and it has its own memory which we can get it with the ID and everything, you know it. Now I'm taking a simple number, x is equals to, I'm taking it 2, 3, 4, 5. This is my number. Now is this an integer? Yes. How to prove that? Just this is, I'm printing it number. Now, how to prove that this is an integer? Okay, how to prove that is this an integer? So just print the type. Type is a function which gets the data type of any value or any variable. Any value or any variable, this will get it. Now, why we are using in combination of the print? Because the print role is to print the data onto the screen, and type is the one which is actually uses to convert. Okay, type is the one which is actually uses to convert the or get, type is the one which gets the data type, and print is the one which prints the data onto the whatever the output is coming, that it will be given or printed onto the screen. Now you see this class int. So why it is showing as class? As I told you, the Python is using an architecture called as, class, class object architecture. It is going to use it over here. Now this is an integer. Okay. Now let me take it the forms of the integer. Okay. Let's see that this is a basic integer. Now let me see some forms of the integer over here. Let's see that binary form. Now whatever is there over here, this is actually okay. Let me convert it into integer, any number, and take any one because we will do this conversion very detailedly in the future, which is called as typecasting. But I will show you just a converting float to integer. Now what is my float value? Y is equals to, now I will take it as 34.54. This is my float value. I want to convert it into integer. As I told you, if you want to convert anything into integer, we are having an int function, right? Int function. So now here I will print it. First I will convert it. Now int of y is equals to, I will take it as z. Okay. Now I will print it as z. Okay. Now I will print the type of z also. Now here you can see this integer. Actually, what is this one? Y, print y, and type of y. Type of y. Now y and type of y are nothing but it is a float type. Now float type we are converting into integer. Again, you may get a doubt that because the basic properties of the fundamental data type are, it is immutable. Now how this conversion is happening from the float to the integer? See, actually original value is not getting changed. So what this int is doing is, it is taking a copy of this value. Okay, whatever the value is there, it is taking that copy and it will store it in the another place. And before storing, it will convert it into integer. Okay, the original value will be as it is only, but only thing what happens is the int function will take the copy of the original value and store it in a different memory, copy of that value and store it in separate, while it is storing in the another place. Okay, while it is storing in the another place, what will happen, it will convert it into integer. That is the reason why you see this here. We are storing this new format of, after converting this one, I'm storing in Z, and my original Y will be as it is. You see this, my original Y will be as it is. The same value it consists of. Clear, guys? This is a starting, then this is conversion, and this is what. So what will happen is, actually the function int, not only function int, the whatever the functions are there, that is what it will do it. It will go and get a copy of the integer and it will store it in a separate memory location. And before storing in separate memory location, it will convert it into integer. That is what it is happening. Okay. Now let's see the different forms of the integer. Let's quickly see this, how it will work. Now let's see this one. First, we will see the binary form. I'm putting a note. Forms of integers. What are the forms of integers? First is decimal form. This is nothing but a default form. Okay, so no need of showing this decimal. Because whenever we print it, we will get the output in the decimal form only, default form. Second one is binary form. This is nothing but the form which you will store it in 0 and 1. This is called as binary form. Okay. Next one is octal form and hexadecimal. Okay, hexadecimal form. Now let's see one after the other. First, we will see the binary form over here. I have a number over here. Let's take a number. A is equals to, I will take it as 1 0 1 1 1. Okay, let's take this number 1 0 1 1. Now I want to print this number. I will print it A over here. What I'm going to get it? I'm going to get it as 1 0 1. What is this form? This is a decimal form. Remember that this is a decimal because our interpreter is understanding this as a decimal form. You are not making your interpreter understand this as a binary form. How you will make your interpreter understand it as a binary form? You will put it as 0 and BO. Once you put it 0 and B, then it is understood that this is a binary form. Now, as I told you, whenever you are going to print a value using the print function, or whenever you are displaying a value using the print function, by default, the output will be in the decimal form only. By default, the output will be in the decimal form. Now let me show you this. 11 is nothing but a decimal form of this binary form 1011 number. 1011 number is there. This 1011 number in decimal form, we will call it as 11. Now, how to prove that? What I will do it is, we know that how to convert any number into binary format. There is a function called as bin. I will use the bin and I will give the 11. If 11 is same as this one, Then when I convert the 11, I should get the same output, right? I should get the same output. I will print it over here. The same thing, I will print it. See, I got the same. This and this is same. So this is the way I'm going to like actually just a minute. Okay. So this is the way we are going to prove that how we can convert a binary value in, sorry, a decimal value or any other form of value. We can convert it into a binary format by using the bin function. By using the bin function, we can convert. So whenever you use it any other form and you will display it using the print function, it will by default, it will display in the decimal form. And if you want to prove that one, what I did it, I converted that resultant value into binary form. I got it same. Okay. Now let's do it with the octal form. Octal form. What is the octal form? With the base 8 and the values will, the numbers which are used to represent it is 0 to 7. So I will take it b is equals to, I will take a number like this, like 561. Okay, something like this. Is this a octal form? Actually, we know that it is an octal form. My intention of writing is also octal form, but I'm not passing on the same information to my interpreter. So this will consider this as a decimal form. 561 is nothing but 561 in the decimal form. But if I want to make this one, my interpreter understand that this is not a decimal form, this is an octal form, then I use it 0 and 4. That's it. Now you see this print, I will give it as B. Now, as I told you, whenever we are any form, I'm printing it, I'm going to get it in decimal form only output. Now I will show you the output in the decimal form. You can see this, that is 369. This 561 is in the decimal form, 369. Now how to know that the both are same? Just convert this one into this octal form. How to do that? We are having a function called as oct, and I will put it as 369. And how much I have to get it? I have to get it 00561. This I will print it as it is. Now you can see. Okay, 560. Now we know that one thing. Here, let's play with it later on. Now, as of now, we will move forward with the hexadecimal form. The hexadecimal. Here, what we will do it is, I will take it as C over here. Okay, let me remove this. C is equals to, I will take it as 0x, and I will use it 894. This one I want to convert it into decimal form. All I have to do it is just print C. That's it. Then automatically by default it will be displayed in the form of a decimal form. That 35,122 is the actual decimal value of 8,932 in the hexadecimal format. And how to prove that? Just convert that one hex of 35,122. Then you will see this output will be the same as C. Okay. Now this is the way you can convert it. Now, can we convert binary into hexadecimal? Can we convert a binary into hexadecimal or binary into octal or hexadecimal into the octal? Can we do that? Yes, you can do it. Anything you can do it. Now let's take a number. Okay, let's take a number in the decimal form. Okay, I will take it my decimal form number as 90. This is in the decimal form. Now this decimal form number, I will convert first into binary. Okay guys, see this. What I'm going to do it is, first I will convert this decimal form 90 to binary. Using the bin function, binary I'm going to convert. Whatever output I'm going to get it, that output I will give it to the octal. And I will get some output. That output I will give it to the hexadecimal. And then I will, whatever the output I'm getting it over here, I will print it. Then what should be the print will be printing in the form of decimal. So my output will be 90. Should be 90. 90 I'm converting to binary. Binary to octal. Octal to hexadecimal. Hexadecimal I'm printing it directly. Okay, that is what I'm going to do it now. And this shows that we can convert it very comfortably one after the other. Now let's do this. Okay. Now let me take it, 90 is the one. I'm converting the 90 into binary, bin of 90. So this I'm printing it as it is. Okay. Now what will be printed? It will be printed the 90 in the binary form. See, I got it, this one. 1011010. Okay, this is 90. Now is this 90 actually? Let's see this one. Print. It as it is and put it over here. Okay. By default, when I'm giving a value, then this will be converted and printed in the decimal format, and I should get it as 90. See, I got it as 90. Perfect. No problem about that. We are comfortable with it. I will remove it. Now next, whatever the output over here where I'm getting, that output I will convert it to octal form. How I'll do it? OCT is the OR. Inside this, I'm going to put it, and I will print it over here. So what I'm going to get it? I'm going to get it as oct in the octal form. 132. Now, is this 90? Let's see this one. I'll take it and print it over here directly. By default, it will convert this one into decimal form and it will show you 90. Perfect. Now I will remove this. Now let's take the whatever the output we got it, I will convert it to hexadecimal. Hex, and I will put it on this one and I will print it back. Print. Now this one should give us the hexadecimal to that is hexadecimal format it has to give it. Now I got it 5A. Okay. Now A, as I told you, stands for 10 over there. Okay, 10 is represented by A over here. Now let me print this one in the, just I want to check it out. The output should be equal to that of 90. Now I will print it. Oh, I got the 90. Now this shows that you can convert any form to other form and the output will be the 90. Okay, one thing is clear. Now let's see this one. Okay, now this is okay. Let me see the data type of them, because all of them are derived from the integer. Okay, all of them are derived from the integer. Let's see that what is the data type. Now we know that how to get the data type of a value. Type is a function. Type is a function. I will use the 90. 90 is the one I gave it right over here. Can you see that 90? I'm putting on the 90 over here. And I'm printing it over here. This is nothing but we will get the integer. We know it very well. We know it. We will get the integer. Okay, int. Now let's take this one, which is a binary, and I will check it out. Type of that. Okay. Now I will run it. What you are going to get it? I will get it the int only. Because it is the base form is integer. All these are integer. Now let's take it this one, which is an octal form, but this base form is also integer. Now, whenever you are giving a coding round, they will definitely sometimes they will ask you this. Okay, they will ask you to confuse you people. So what is the data type of the binary format? So all of them will be in the integer only. Yeah, all of them are integer. Okay, now let's move on to the next data type, which is called as float. Now this is we went very detailedly from all the prospects, so that if you have a coding round or if anyone asks you about this, so that you can answer it. Now let's go on to the next one called as float. Now float will not have so many like different types of forms. Float is having a only one form, which we call it as exponential form. Okay, let me I will put on a circle or square around this so that it is easy. Okay. Now let's move on over here to the float form. Float. Now what is float? Float is nothing but an integer with a decimal. Now what is an integer for us? Integer is nothing but it can be a positive number or a negative number or a with zero. Okay, okay, zero without any decimal point. Now here integer with a decimal point is called as a float. Integer with decimal point. Float. Now what is the advantage of this float? First, you can get an accurate value which is displayed or represented using decimals. So you can get a very much accurate value. Now here in integer, you usually get it a round up value. Okay, remember that. Usually you will get a round up value, whereas the float will give you a accurate value. Okay, it is a float is a data type which provides you an accurate value, which gives the facility to represent an accurate value. Okay, the resultant value, whatever, it gives us the accurate value. Decimal, okay, using the decimal point or in decimal point, you can write. First, second important point why we have to consider or why you have to give a respect to the float is, if you take it any two numbers, okay, let's take any two numbers over here. Now I will take it as, I will make it as 3 and 6. I will ask you how many numbers will be there with this. Then you may say it like three numbers are there. What are the three numbers? 4, 5 and 3 and 4. Only 3 and 4 is the two numbers are there, not 2 and 4 and 5 are the two numbers is there. In between this, right? I'm not considering the 3, I'm not considering 6. We are having only two numbers over here. So we know that only two numbers are there. Okay, that is two numbers. This is having two numbers. If I say 3 and 5, how many numbers are there? You will say that only one number, that is 4. Here only two numbers, that is 4 and 5. This is only 4. Now, if I ask you how many numbers are there in the 3 and 4, now you will say that it is 0 numbers because there is nothing is there. Now, when we are considering these numbers as integers, okay. Now, if you are looking these numbers from the float prospects, then you can generate infinite numbers between 3 and 5. 3 and 5, you will get it infinite numbers. If you go on saying these numbers between 3 and 4, it will never end and you will never repeat also. That is what it will happen. Without repeating the same number, you can give a n number of numbers between 3 and 4. A simple example, 3.3. 0, 0, 0, 0, 0, 0, 0. This I can go on putting the 0. Now, if I say that again, 0, 0, 2 over here. Now, this is the way you will be going on giving infinite number of values. You can take it 5 zeros, 10 zeros, 100 zeros, 200 zeros, or 300 zeros after the decimal point. So this is the advantage. So the float can generate infinite number of values between any two values. Between any two values, it can generate infinite number of values between any two numbers. Between any two numbers, if you take it, this is the situation. Okay. Now, how example of the float is, we have seen it, the floats. Now, example of the float, how it look like, 68.27. Next one is 92.44, or you can take it as 1.01. This is also a float. Okay. Now, this is the way the float is represented. And the float is having its own default function called as float function. This float function helps us to convert any form, any number into float form. Convert any number to that is float type. In other words, float type. Now, float has only one type of form, guys. That form name is called as exponential form. Now, what is the advantage of this exponential form? See, exponential form is actually, what is the advantage of this is, whatever may be the biggest number you are having, that you can display it in a limited number of digits. That is the advantage. Whatever may be, how big may be your number, you can restrict or you can display that or you can present that number in a using a very limited amount of digits only. Limited digits you will use it and you will put. Only in the same number of digits, you can go on giving the bigger number. There won't be any extra digits will be added to that. Now, a simple example. Okay. Now this form helps us to hold the biggest value or biggest value in a limited digits only. That is what. Digits. Now, for example, over here, how this exponential form look like. So if you have it a number like, see this guys, if you are having a number like 1200, and let's take it one more is 12,000. Okay, the one more is 12. Okay, 1,20,000. Okay. Now this is the way. Now this is occupying 4 digits. This is occupying the 5 digits, and this is occupying the 6 digits. Now as the number is growing, now it is occupying the more digits. Now you see the advantage of the exponential. This we will have it. We can write it as 1.2 e to the power of 3. Now, what is this is nothing but this is 1.2 into 10 to the power of 3. The 10 to the power of 3 is what? 1000. Okay. 1000 into 1.2 is nothing but 10 is gone to remove the decimal, and remaining 2 zeros will be coming up. That is nothing but 1200. See the same over here and same over here. Got it? Now, see, now you may say that this and this looks same number. Let's see this one. 12,000. 1.2 e to the power of 4. That's it. The same. And let's do this one. 1.2 e to the power of 5. And if you say this, 1.2 e to the power of 8 means what will happen is 2 after this you will have 8 zeros. That is the number over here. 1, 2, 1, 2, 3, 4, 5, 6, 7. 7 zeros are there. Okay. So you will be getting 7 zeros. Then we will say that 1 to 1.2. See this, how big the number, the same space it is occupying over here. Got it? This is the advantage of the exponential form. Now, exponential form is really like, you can see this automatically when a, if you take it and maybe calculator over here, I think that it should be converting it if the bigger number is there. Now I will take a number over here. Let's take it as my number is something like this. This is a bigger number. And let's take it some numbers. And I will use the multiplication. Again, I will write it as some numbers over here. Now I will give it as. Now you see this automatically I got it in the exponential. This is e to the power of plus 20. Now if I go on doing it, you see within the same limited number of space, it is going on increasing the number. See this, it is e to the power of 414. That is this number. After this, we are having 413 zeros are there after this. You can understand that. Now, see this, how big you want to go, it will be the same, it will never say more. That is the advantage of your exponential. Okay. Now, that is why we usually what we will do it is we will ignore the real importance of your float and we will be moving on. Now, again, this I can't show you the exponential form in the programmatically, but that is the way it will be stored. Now, let me show you this and how it will work quickly. Then we can go on to the next data type.